Okay, so far we've learned how to balance equations and predict products. And down here I have an example of one that we've done in the past. So we had potassium iodide and then lead nitrate. And the products that we predicted, since this was a double replacement reaction, were potassium nitrate and then lead iodide. And you can probably see on the reactant side of this equation, we have the symbol for aqueous. So both of those are aqueous compounds. And so we're going to build on these skills and go one step further. And we're going to figure out now what is going to go, what's going to go next to our products. So we need to figure out, are these products going to be aqueous, or are they going to be solid? So that's what we're going to learn today. And we're going to use, in the reference table, we're going to use table F. So to use table F, everything on the left side here, these are all things that are soluble. So if something is soluble, that's considered aqueous because it's dissolving in water. And everything over here on the right side, these are insoluble. And so if something is insoluble, it remains a solid when it's in water. So these are solids. These are, over on this side, these are going to be aqueous. So if we look at something like potassium nitrate, what you want to do is look for, you can either look for potassium or you can look for nitrate. In this case, you can look for either because they're both on this table. And so you can see that in the top here, group 1 ions are under the column that says ions that form soluble compounds. So because potassium is a group 1 ion, it's in the first group of the periodic table, all of those compounds are going to be considered soluble or aqueous. So if you also look right here at nitrate, everything that contains nitrate is also going to be soluble. So based on that, we can assume that potassium nitrate is going to be aqueous because it is soluble. It's going to dissolve in water. So just remember, aqueous is soluble. And then if something is a solid, that is insoluble. So don't get these S's mixed up because they don't mean the same thing. All right, so now let's look at lead iodide. So lead is not on this table, but if we look for iodide, that is right over here under the halides category. And so everything that is, or every compound that contains chlorine, bromine, and iodine, these are all considered soluble compounds. But if you look over at the right side, there are some exceptions to these rules. So yes, every compound that contains iodine is soluble, except when it is combined with lead, silver, or mercury. So because lead is in our exceptions category, this is actually going to be considered insoluble. And so if something is insoluble, we put an S for solid because it's not dissolving in water. Okay, so let's look at a couple more examples here. We're going to do sodium hydroxide. So you can either look for sodium or you can look for hydroxide in this table. And let's just do both just for some practice here. So sodium is a group 1 ion, so that would be right up here at the top. And you can see that group 1 ions are always going to be soluble with no exceptions. So this should be soluble, but let's take a look at hydroxide. So hydroxide ions are over on the right side, which means that things that contain hydroxide are usually going to be insoluble or very low, or a very low solubility. But if you look at the exceptions, hydroxides are insoluble except when combined with group 1 ions. And sodium is a group 1 ion. So this is soluble, and so it would get the AQ symbol, or the aqueous symbol. Now if we look at something like magnesium hydroxide, magnesium is in group 2, so it's not a group 1 ion. And so all hydroxides, or everything that contains hydroxide, is insoluble, and magnesium is not in our exceptions column. So because of that, magnesium hydroxide is considered insoluble, or doesn't dissolve in water, and that would get the S symbol for insoluble or solid. I know it's a little bit confusing, but it's important to remember that S is solid, not soluble. Okay, so let's look at something like cesium sulfate. So cesium is a group 1 ion. So let's look for that, or we can look for sulfate. And so sulfate is right here over at the bottom. And everything that contains sulfate is going to be soluble. So everything on that left side, again, is soluble. And sulfate is always going to be soluble except when combined with these ions. And cesium is not one of those ions. So cesium sulfate is going to be soluble. And so this would be considered aqueous because it's dissolving in water. All right, now let's look at the other one, which is silver sulfate. So again, we'll go up here to table F, find sulfate, and every sulfate, or everything that contains sulfate, is soluble except when combined with silver, calcium, strontium, and so on. But silver is one of our exceptions. So when silver is bonded to sulfate, it is not soluble anymore. And so this would be considered insoluble. And so because it's insoluble, it's not dissolving in water, it would be a solid.